JIT and Lean Systems. Just in time, or JIT, is a production philosophy that started in Japan. It was developed by Taichi Ono at Toyota Motor Corporation as a part of Toyota production system. The main idea of JIT is simply produce only what is needed, when is needed, and in the exact amount needed. Instead of storing large amounts of materials or products in a warehouse, companies receive materials at the right time for production. This helps reduce storage costs, avoid overproduction, and minimize waste. Toyota is mentioned in this topic because it is one of the first companies in Japan to successfully apply modern quality management systems like total quality management together with JIT to improve efficiency and product quality. Now, let's talk about lean systems. Lean is a broader management philosophy while JIT focuses mainly on reducing inventory. Lean focuses on eliminating all types of waste in an organization. These wastes include overproduction, waiting time, defects, excess inventory, unnecessary movement, and overprocessing. Lean aims to improve the entire process from suppliers to customers by continuously improving these operations.
Waste is defined as any activity that does not add value to an operation. In simple terms, if an activity does not help improve the product or service for the customer, it is considered waste. The concept of eliminating waste is one of the key principles introduced by the Toyota Motor Corporation through their production system. Toyota identified 7 types of waste that commonly occur in operations. First is overproduction. This is considered the greatest source of waste. It happens when a company produces more than what is needed or produces items earlier than required. When there is overproduction, it leads to excess inventory, higher storage costs, and possible product damage. Second is waiting time. This refers to the time when workers or machines are idle and waiting to continue productions. Instead of adding value, time is wasted. Sometimes companies try to hide this waiting time by producing unnecessary work in progress or WIP, but this only converts time waste into inventory waste. Third is transport. Unnecessary movement of materials or product from one place to another is also a waste. Poor factory layout often causes this problem. By improving the layout, transportation, time, and cost can be reduced. Fourth is process. Some processes do not add value to the product. This may exist because of poor design, outdated equipment, or lack of maintenance. Improving product design is practicing preventive maintenance can help eliminate these unnecessary processes. Fifth is inventory. Excess inventory, whether raw materials, work in progress, or finished goods, is considered waste. Too much inventory ties up money, requires a storage space, and may become obsolete or damaged. Six is motion. This waste refers to unnecessary movement of workers or equipment. For example, walking back and forth to get tools or materials. By simplifying work movements or organizing the workspace, productivity can improve. Seventh is defective goods. Defects result in scrap materials, rework, wasted labor time, and delays in delivery. Poor quality also damages a company's reputation and customer trust.
Continuous improvement, also known as Kaizen in Japanese, is a philosophy that emphasizes ongoing, incremental enhancements in processes and operations. It is based on the belief that achieving the ideals of just in time can be accomplished through a steady flow of small improvements over time. This approach encourages all employees to participate to identifying areas for improvement and implementing solutions regularly. By consisting refining processes, organizations can increase efficiency, reduce waste, and enhance overall quality. JIT, or just in time, is a core ongoing effort to eliminate waste, optimize workflows, and enhance quality by making small, incremental changes. It drives JIT by empowering employees to refine processes daily, reducing inventory and improving cycle times, and ensuring product matches demand. Sometimes it's a way of producing only what is needed, when it is needed, and in the right amount. This helps avoid excess inventory, saves space, and reduces waste.
The pull system takes its cue from the supermarket's operation. Customers only buy the items they need and new stock is replenished when an item is sold. The inventory levels are determined by customer demand and replacements only occur when the products are taken out of the system. To make a pull system work, a Kanban, which means card or sign in Japanese, is used for the transfer of information throughout the production process. Each Kanban contains the part type, the amount per container, the previous and next workstations, and serve as a signal for the production and move of materials. Kanbans do not determine the exact production schedule, but they play a very important role in granting the flow of materials. Without them, production will not move on. They can exist in different forms apart from cards. For instance, a design area on the shop floor that signals when to produce or move its item can be used. Kanban system can be categorized mainly into two types, single card and dual card systems. In the single card system, only a Kanban for conveying is used to allow the movement of parts, which means the number of containers or a certain work center is equal to the number of canvas. A container is not refilled until it is completely empty, which indicates the need for new parts. For example, Toyota is using a dual card system that assists in the production and inventory control by using a conveyance Kanban along with a production Kanban. This strategy allows for more accurate management, particularly when there are closely linked processes which in one Kanban can be used. It is a must that seven operational rules are strictly adhered to for the Kanban system to operate effectively. This way, smooth and the consistent production flow is guaranteed within the pool system. JIT pool systems. The pool system concept aims at reducing the amount of inventory in the manufacturing process. A push system makes a schedule that forces workers to work on machines one after another, then passing the output to the next workstation that often has to stock excess inventory in order not to wait for the next machine to finish. This really means that it is very hard to get parts all the way up to each particular machine exactly when they are needed. So they have to be stockpiled at certain points in the production process.